Welcome to Math TV with Professor V. This is video lecture number 32 for intermediate algebra, and we're kicking off unit 7 on exponents and radicals. Listen up, this is something even my calculus students struggle with, so if you need a good refresher, here it is. So first we're going to talk about radical expressions and functions, and I want to get one thing straight. There's a big difference between -7 squared with the negative on the outside, like so, and then the quantity -7 squared, because we're going to be talking about square roots in just a second. So we all know +7 squared is 49. If you have -7 squared, what that means is you have -1 basically times 7, so this would be -49. However, if you have the quantity -7 squared in parentheses, the exponent says you write out everything inside the parentheses twice for this case. So that would be -7 times -7, which is +49. So the result is different. Pay close attention to where the minus sign is. If there's no negative, then it's straightforward, right? 7 squared is 49. And when we raise a number to the second power, when the exponent is a 2, we often say that we're squaring it, like I just said. But often, and in this unit, we're going to work on reversing that process, finding what number was squared in order to produce a specified value. So in this whole chapter, we're going to reverse things. And you probably can do a lot of this off the top of your head. Suppose you knew that a squared is equal to 36. Then what is a equal to? Well, you actually have two options. A could either be 6 or it could be -6, right? Squaring both of those values would result in +36. And now we're going to get into some definitions, which can be a little bit tricky. So definition, square roots of A. So we say that the number C is called a square root of A if C squared is equal to A, okay? So in the previous example that we just looked at, 6 is a square root of 36, and -6 is also a square root of 36, because both of those numbers squared gives you 36. However, we can be more specific, and sometimes we're interested only in the principal square root. And the principal square root refers to only the positive square root. So if I were to ask you, what's the principal square root of 36? You should just say 6. And the way that we denote that we want the principal square root is we use a radical sign, square root of A. And this is where even my advanced math students make a mistake. Because if I just ask you, what is the square root of 36 like this, you should only write the positive or principal square root, because that's what this symbol indicates, okay? This is 6. It is not plus or -6. When the radical is already there, it's telling you we want the positive, we want the principal square root. Don't be giving more than one answer, okay? You only put plus or minus when you apply the square root and it wasn't there originally. We'll talk about that later. Okay, so please pay very particular attention to directions, notation, and all of that. So example, A, the square roots of 64 are. So this time they want both square roots, not just the principal. So the square roots of 64 are 8 and -8. Okay. B, this symbol means we want the positive, the principal square root of 81. So you should only have one value here. This is 9. C, negative square root of 64. So the positive or principal square root of 64 is 8. And then we apply a negative to that value. Okay, so that's it. Just one answer. Just one answer. And then here, last one we have is square root of -4. This is not a real number. You might already know that's equal to 2i if you've studied complex numbers a little bit, but for the purposes of this lesson, we're just going to deal with real numbers only, okay? Good. So a little more definition just to clarify. If a is a positive real number, then square root of a, or radical a, is the positive principal square root of a. And then when you have a minus sign outside the radical and then a, that's the negative square root of a. Okay? In the expression square root of a, this symbol right here is called a radical. And a, the stuff underneath the radical, is the radicand. Ooh, look at that vocab for you. Okay. Now another definition, rational versus irrational numbers. I think the easiest thing to keep in mind is that a rational number can be written as a ratio of two integers. Can be written as a fraction. Can be written as a ratio of two integers. Also, keep in mind that the square root of n is rational if n is a perfect square. So if n is 1, 4, 9, 16, 25, etc., then the square root of n is going to be a rational number. An irrational number cannot be written as a fraction or as a ratio of two integers. And the square root of n is irrational if n is not a perfect square. So something like square root of 5, square root of 21, square root of 23, etc. Those are all irrational. Rational would be square root of 4, square root of 16, square root of 144. If this idea is a little fuzzy, I have a short video on irrational versus rational numbers. I'll link it here, where I give lots of examples. Okay, so now let's get into classifying. So we're asked to simplify and then identify each number as rational, irrational, or not real. So first one is square root of 11. 11 is not a perfect square, so I can't simplify it any more than it is. Is it rational, irrational, or not real? Well, I just said 11 is not a perfect square, so this guy's irrational. Okay, what about B, square root of 169? Well, the square root of 169, that's 13. Hopefully you have your perfect squares memorized. 169 is a perfect square, so this is rational. Notice 13 is a rational number because you could write it as a ratio of two integers, 13 over 1. Last one, square root of negative 25. If you have a negative underneath the radical, if your radicand is negative, look at me using vocab, then this is not real. And you don't say rational or irrational anymore, okay? Real numbers are the only ones that can be rational or irrational. If it's not real, you don't use that classification on them, okay? Good. Now we're going to look at the graph of the square root of x, and we're asked to first find the domain of the square root function. So let's think about when we have the function f of x equals radical x. What values am I allowed to plug in for x so that f is a real number? F is well defined. Well, I can plug in pretty much anything I want, just so much as it's not negative, right? We talked about that just a second ago. And also, let's think about, besides negative numbers, 0. Is 0 okay? The square root of 0, it's just 0. 0 times 0 is 0, so we're good to go. So the domain is all x's such that x is greater than or equal to 0 for square root of x. If you want to write that in interval notation, you'd put a bracket, 0 to infinity. Okay, and then the next part asks us to graph the function. If you don't already know what it looks like, then let's make a table. So x, and then f of x is square root of x. So I'm going to plug in 0, because that's the smallest number I'm allowed to plug in. Square root of 0 is 0. Then let's do 1. Square root of 1 is 1. I'm not going to plug in 2. Why? Because it's my graph, my table, and square root of 2 is about 1.4. It's irrational. I don't feel like graphing decimals, so we're going to skip it. We're going to skip 3. The next x value I'm going to plug in is 4. Square root of 4 is 2. You know, don't make life harder on yourself than it needs to be. What's the next one I want to plug in for x? Oh, 9. Square root of 9 is 3. See, look at that. Look at me not stressing myself out for no reason. Okay, so we've got 0, 0. Here's my x-axis. Here's my y-axis. 1, 1. 4, 2. 5, 6, 7, 8, 9, 3. Like this. Ooh, lovely. Only put the arrow on one side, please. This is just nice closed circle. Stop. Because remember, the domain, the graph doesn't exist over here. Domain is 0 to infinity. Okay. Now, what would the domain be if we changed the function slightly? What if we made it square root of x plus 4? Well, the same basic principle applies. Your radicand, so the stuff underneath the radical sign, has to be greater than or equal to 0. It can't be negative. So what you would do is you would just take whatever you see underneath the radical and you set it greater than or equal to 0, and then you solve that inequality. That would give you the domain of that radical function. So I could just subtract 4 over, x is greater than or equal to negative 4, and that's my domain, believe it or not. Okay, easy enough. So general rule of thumb, if you have f of x equals square root of something, then you set the something greater than or equal to 0 and solve. Now keep in mind, inequalities are trickier to solve than equations a lot of the time, so if it's quadratic or something more spicy, you have to do it carefully. But if you just have a linear expression like x plus 4, it's not too bad. Okay, moving on. Let's let f of x equal x squared minus 25. Find f of negative 6. So let's go ahead. F of negative 6 is going to be the square root of x squared, so that would be negative 6 squared minus 25. Negative 6 squared, remember that's positive 36 minus 25. So what's this going to give me? Square root of 11. Leave it here. This is completely simplified. Don't get your calculator out. Nobody wants a decimal, only if you're asked for it, okay? This is our exact, beautiful, unrounded, untarnished answer. Okay. Very good. Now here's something that's going to be a little bit new for you, especially in intermediate algebra. Simplifying the square root of a squared. So whenever you see the square root of a squared, that's not equal to just plain old a. It's equal to the absolute value of a. Why is that? That might freak you out. Well, since a is unknown, and we know whenever we see this symbol here, that's the principal or positive square root, right? So the result from this must be positive. The absolute value is required. Let me give you an example, okay? Say I let a equal 3, okay? And then I want to figure out what is the square root of a squared. So what is the square root of 3 squared? Well, it would be the square root of 9, which is 3. Now, what if I let a equal negative 3? Well, the square root of negative 3 squared is the square root of 9, which is 3 again. So notice, if a is positive, the result is positive. However, when a is negative, the result is positive. So regardless of if a is negative or positive, the result from taking the square root of a squared is that you always get a positive number. How do we guarantee that we always have a positive or a non-negative number? You put absolute value, you take its absolute value, okay? You might be thinking, I don't remember this being a problem. I remember just taking square root of a squared and it was a, and I could just live my life carefree. Well, usually in your beginning algebra courses, the directions will say something like assume variables represent non-negative values or something like that. So basically it tells you you don't have to stress about the absolute value because we're assuming the variables aren't negative. Yes, you've been living in ignorance. Okay, so let's simplify. We have the square root of x plus 2 squared. So basically taking the square root of this squared quantity, they'll undo each other. But since we have a variable underneath the radical, I need to put absolute value. That's it. Then we have square root of negative 7c squared. This is going to be absolute value of negative 7c. You could simplify that a bit more, but I'll just leave it there for now, okay? And as a note of caution, one of the most illegal things I see students do that the math police just hop in their little speed racer and come get them for, square root of a squared plus b squared does not equal a plus b. You are not allowed to split up a square root over addition or subtraction. Most famous counterexample, let a equal 3, b equal 4. Square root of 3 squared plus 4 squared is the square root of 9 plus 16, which is the square root of 25, which is 5. In no way does that equal 3 plus 4, which is 7. Do you see that? Okay. So don't even think about it. Now, like I mentioned earlier, often we're going to specify ahead of time that no radicands were formed by raising negative quantities to even powers, and then this allows us to disregard the need for absolute values. Okay? So basically, don't stress. You can just cancel everything out and not put absolute value in your answer. So that's precisely what the next couple exercises say right here. Simplify. Assume no radicands were formed by raising negative quantities to even powers. So in your brain, just think, no absolute value. Hooray, we can relax. So a, square root of 6b squared is just going to be 6b. Look at part B. What in the world am I supposed to do? I just told you you're not allowed to split up a square root sign over subtraction and addition. So we need to figure out how to write this as something squared. Hopefully it factors. 9t squared, that's 3t times 3t. The middle sign is negative and a 2. Is that how it factors? Yes. So square root of 3t minus 2 quantity squared is just going to be 3t minus 2. And I'm not putting absolute value because I know the variables are not negative numbers for this set of exercises, okay? And then now that we're so proficient at square roots, we're going to talk about higher roots, cube roots, etc. So we say that a is a cube root of b if a cubed is equal to b. And the way you would indicate that a is a cube root of b is by writing the following: a equals cube root of b. So if you want to think of some examples numerically, like 2 is a cube root of 8, since 2 times 2 times 2, or 2 to the third power, is 8. A number will only have one cube root. It can't have a positive and a negative because cube root 3, that's an odd number. Negative 2 times negative 2 times negative 2 would actually give you negative 8. So these are different than square roots. And notice in writing this, the cube root of b, that number 3, that little baby number, is called the index of the radical. So that tells you what root you're taking. When the index is 2, we don't write it. So for square roots, you don't see us writing this 2. It just is omitted. That's not that weird. Like when you have plain old x, you know the coefficient's a 1. We just don't write it. Same idea, okay? If it's anything other than a 2, then we indicate what it is. So you could take a cube root, you could take a 4th root, a 5th root, etc. So just pay attention to what that little number is, okay? Good. So let's find the following roots. First one is cube root of 27. So can you think of a number you would multiply by itself 3 times that gives you 27? Yeah, it's 3, positive 3. Okay, part B, cube root of negative 27. Now, cube roots are different than square roots because 3, that's an odd number. Don't freak out that this time we have a negative radicand. Since this is an odd index, we can compute this quantity. This is negative 3. Like I mentioned a second ago, negative 3 times negative 3 times negative 3 is negative 27. So don't go default, like anytime you see a negative under the radical, you go, oh, it's not a real number. It's not going to be a real number only when the index is even. But for odd ones, you can do them. Okay, C, 4th root of 16. So can you think of a number, multiply it by itself 4 times, you get 16? It's 2, right? 2 times 2 times 2 times 2 is 16. D, 4th root of negative 16. Okay, so this time the index is an even number. You cannot take an even root of a negative number and get a real number. So this one is not real. Okay, that's it. So keep that in mind. You can take odd roots of negative numbers and get a real number, but even roots of negative numbers are not real. All right, consider the function f of x equals cube root of x. What is the domain of the function? Well, we just looked at the domain of square root of x, and remember x had to be greater than or equal to 0. But right now we talked about the fact that you can take odd roots of negative numbers. So for this function, cube root of x, since this index is odd, I can plug in anything I want for x. 0, positive numbers, negative numbers, it's all good. So I would say the domain is all real numbers, or you could write negative infinity to infinity. What is the domain of f of x equals cube root of x minus 4? Again, all I need to pay attention to is the fact that this index right here is an odd number. So domain is all real numbers. We have no restrictions. Relaxing, huh? Okay, a couple more examples. Let f of x equal the cube root of 2x plus 5. Find f of 11. All right, so f of 11 is going to be the cube root of 2 times 11 plus 5. So that's the cube root of 22 plus 5. So cube root of 27. And what is that? That is 3. Oh, okay. That's it. Just to help you practice using function notation while taking cube roots. Last set of examples now are simplifying. So 7th root of x to the 7th. Notice since this is an odd index, then I'm just going to end up with x. I don't need to put absolute value of x because you can take the odd root of a negative number and it will still come out negative, okay? Here we have, for part B, the 4th root of 81x to the 4th. Since this is an even index, then I have to be careful. Do you know the 4th root of 81? I'll tell you a quick way to do 4th roots. You just take the square root 2 times in a row. So square root of 81 is 9, and then square root again is 3. But I need absolute value on the x since this is an even index. Okay, so here's the main idea. Like if you have square root of x squared, that's absolute value of x. If you have cube root of x cubed, it's just x. 4th root of x to the 4th, absolute value of x, etc. So when the index is even, like this is even, then you need the absolute value. But if the index is odd, then you don't. Okay, so that wraps up the lesson. Give the video a thumbs up, subscribe if you haven't already. And then I already have the next video uploaded, rational numbers as exponents, but I'll be working through the rest of the units shortly. Stay tuned.